Yes, good evening, everyone. Thank you for your greeting. So let us start now. So today, guys, we are entering to the main crux of the biostats. So in biostatistics or in statistics, you have two types of statistics: descriptive statistics and inferential statistics. Now, inferential statistics, maybe we will learn maybe after 1 week or maybe after 2 or 3 classes. We are starting with descriptive statistics. So descriptive statistics is nothing but when you have a huge data, like suppose you are collecting 2000 to 5000 sample data. So if somebody wants to know, can you tell me what kind of people are there in your sample? On whom have you done the research? Can you describe your data? So if you want to describe a huge sample data of 5000 number or something, so you are using descriptive statistics. So you're organizing your data, you're summarizing it into short tables, you're presenting the data in an informative way. So for example, if I'm trying to test the safety and efficacy of a drug in, let us say, in any patients, in any group of individuals. So I want to know how many sample have you collected? Then you will say sample size n is equal to 5000. So if I want to know how many of them are male and female, so you're telling, you will calculate, you will do some statistics and you will say male people are 50%, female also 50%. In that, I would still want to know what is the average height of your entire population, average weight of your entire population, BMI of your entire, sorry, it's not population, it's sample. You have to use the word sample when you're collecting a data of 5000. You can use the term population when you're doing a census based study, when you're doing the entire country like that. So here I have mistakenly told it as population. So I'm wrong here. It is only sample. So if I want to know what is the overall height of your sample, overall weight of your sample, and body mass index of your sample, then you are doing some descriptive statistics and you're telling me. So the average height of my sample is 150.5 centimeter, like that's something you will say. So you are not showing me the entire 5000 sample data and you're not telling go check this file 5000 rows. That is not the way you submit to any regulatory agency or authority. So first you describe any data, you summarize your data. What is the total data? You're describing your population. That is called descriptive statistics. So example here, the average test score for the students in a class to give a descriptive sense of a typical score. Overall, I don't want all the students' grades. Overall, tell me the students are studying well or not. So I will take out the average test score and I'll say most of the students have scored 80%, like that. So similarly, according to consumer reports, there were 2.5 problems per one copying machine in 2006. So for one machine, there were 2.5 problems. So how did they calculate this? The average. So they have, so in a country there are so many machines, but on an average, how many people have got the problem? So that is like describing your data. So to describe your data, to use two particular parameters, descriptive statistics. One is measures of central tendency and measures of dispersion. So in measures of central tendency, you have mean, median, mode. In measures of dispersion, you have range, standard deviation, quartile deviation, variance. There are so many things. In mean also, you have arithmetic mean, geometric mean, absolute mean, and deviation also you have absolute deviation. So there are a lot of things, but we are studying with respect to the clinical trials and biostatistics. We use the most common things, mean, median, and mode here. And here we use range, standard deviation, quartile deviation, and variance. So let us understand the central tendency. So the tendency of for a set of values to gather around the middle of the set is called as central tendency. As the term indicates, central. Central means in the center. Tendency means the tendency of how many values are lying towards the center. So this is the ideal graph that we have to expect in any data. So this is called normal distribution curve. We will learn about normal distribution curve in upcoming classes, guys. Okay. So normal distribution curve means your shape, when you plot your data, the shape of your graph has to be like this bell-shaped curve. So mean, median, and mode. So if your curve is like this, we say left skewed data. And if your curve is like this we say right skewed data. So this kind of curves are not expected in statistics. If it is there, then decision making is different. So you have different types of tests like t-test, z-test, and non-parametric test, which test to decide if the graph is in this shape, which is the right test. That is a decision making chart. If the chart is like this, what is the test we need to apply? So this is what we will be studying in upcoming classes, but this graph is very much important. So measures of central tendency means, suppose you have all the huge data, most of the data falls under which middle of the set. So at the center of your data, where does your values lies? That is called measures of central tendency. So mean, median, and mode. That is the meaning of central tendency. So we will see this graph later, okay? So let us understand mean. So for ungrouped data, there are two types of data for ungrouped data. We will see for grouped data later, okay, in the next class. Today we are studying all for ungrouped data. Now what is ungrouped and grouped data? I thought I'll say later. Let me show you the slide. So let us take one example over here. Ungrouped data. Data that has not been organized into groups is called ungrouped data, and it is called as a raw data. So whatever we are collecting in our research is a raw data only. Okay. All the statistical tools, softwares that we use only raw data. So for example, a researcher measures heart rate of 20 patients and records as in beats per minute as like this. So for 20 people, this is 70 beats, 75 beats, 70 beats like this. So the person has trying to calculate it, the mean. He got the mean as like this. I'll tell you how to calculate later. Now the same data if I want to organize into some group. This is unorganized, no? This is ungrouped. If I want to organize, I want to tell how many of them got 70. 1, 2, you count here. How many of them got 73? And I think 3 people got 70. So like that, I'll count how many people got 75, how many people got 90, how many people got 85. So that is called grouping. So if the data has been organized into groups, this is called as a frequency distribution. Frequency. How frequently 70 is repeated? How frequently 75 is repeated? Frequency, you're counting the number, that is called frequency. Such a type of data is called frequency distribution. So you see here the mean is 78.5, right? Now suppose if I group this, I will get the data like this. 70 was seen in 3 people. 75 was seen in 5 people. 80 was seen in 7 people. 85 was seen in 4 people. And 90 was seen in 1 people. So like this, if you do this kind of calculation, also if you do, you get the same value 78.75. So this is used when people want to do the calculation manually. They don't have statistical tools and all. But however, all our data is in raw data, ungrouped data. Okay. So did you understand grouped and ungrouped? So the calculations is different for grouped and ungrouped. We will see today all the calculations for grouped only. Okay. So let me just go back to that slide. So we are learning first, we are learning the mean. So for ungrouped data, the mean is calculated as sum of all the sample values divided by number of sample values. So to compute the mean, you have to use the following formula. So this symbol is called as sigma E. It's looking like E, but it is called as sigma. So it's here. This symbol is sigma, and X, and that line above X is called X bar. So X bar is called mean over here. This is the meaning of mean, symbol of mean. X bar is the mean. X is individual value. Small letter n, small n is called sample size. Okay, so this is the sample mean. So if mean is the most commonly used measure, and it is useful for a data set that does not have outliers. This is very, very much important. Your data should not have outliers. Now, what are outliers? True extreme values or two minimum values. Okay, two extreme and two extreme means two minimum and two maximum. For example, height of all the Indians are between 150 to 160. Somebody's height is 140 and somebody's height is 175. This is too much minimum and too much maximum, lowest and highest. Too much variation. Such data is called outlier. So whenever you don't have outliers, then you can use mean. That is a most commonly used measure. So these values might be different. The outliers values might be different from the rest of the data. Such data you have to remove or you have to replace it by something else. So the mean is always the sum of the values divided by number. Let us see here there is a set of data sets. 3, 4, 5, all this. So count all this 3 plus 4. 4 plus 5. You have to count everything. Do the sum of all the values, you will get 66. So if you count your total number of samples, there are 11 digits, right? 1, 2, 3, 4, 5. This is 6 digits and these are 5 digits. Total, the sample size is 11. So 66 divided by 11 is, the mean is 6. Okay. So next, so I'm not giving any practice problems for all of you guys because we are learning for our knowledge purpose over here. But practically, guys, everything is done. The biostatistics is done today only by softwares. And in clinical trials, only the R programming or clinical SAS only is allowed the software to be used. Whereas in colleges, people use SPSS because like I also have SPSS installed in my laptop. So everybody use different softwares. And if you're not using software, you say that I calculated using Excel, I did it myself. They will not give you any reward for that. Rather, they will scold you because the manual calculation or Excel will might give you sometimes wrong because of your mistakes. Whereas if you use software, there cannot be any chance of manual errors. So that is why they will say R programming or SAS should be used for clinical trials, and that is why we are not practicing. But we can practice something on Excel after a few slides. For the complex data, we will practice on Excel because these softwares are very expensive. So if you're doing a small research project, not for drug development, only at academic level, then you can use Excel. You can use any other calculator or like that. So we will practice using Microsoft Sheet or any Excel we can use. We will see those examples later, how to calculate. So now we will understand first the concept. The next is median. Median is always the middle number in a set of data. So median always means you should first arrange the numbers from the smallest to largest or just to smallest. Anything, any order you can arrange. Ascending order or descending order. Both of it you can add and you can arrange them. Then you can find the middle number, that is the median. So let us take one example over here. So here you have a set of data. Arrange this in ascending order. So first is 10, then we have 15, then we have 42, then here we have 55, then we have 68, 72 and 79. So it is visible that the middle number, because median is always the middle number. So the middle of this entire data is nothing but median. Median is would be 55. So what if here this is odd numbers, but if it is even number, then how do we calculate? So if n is odd, this is the formula, n plus 1 value, means that position. And if n is even, this is th value again, that particular value. So let us calculate the median in this way. Let us apply the formula. Okay. So n plus 1 divided by 2 value. So for us actually the data is odd. No, we will apply this formula. Okay. N plus 1 by 2. So let us take this particular example again. So what is the sample size over here? Sample size n is equal to 7, right? Am I right? Yeah, it is 7. Now you have to arrange in ascending order and then you write your position number. First position, second position, third position, this is fourth position, this is somewhere fifth position, sorry, fifth position. So let me just make this space. This is third and this is second, third, and this is fourth, and then this is fifth position. Then similarly we have sixth position, and then finally we have seventh position. Okay, you have to write the positions. Then n plus 1 divided by 2. N plus 1 divided by 2 means 7 plus 1 divided by 2. What is 7 plus 1? 8. So 8 divided by 2 is 4. So if you use the formula also, the number that is lying at the fourth position, because we have the formula n plus 1 divided by 2, and here we have th. Th means that position, the value that is in that position. So n is 7. 7 plus 1, 8. 8 divided by 2 is 4. So the value that is falling at the fourth position is the median, 55. So like that, whether you apply the formula or you visualize, you got the same answer. So that is median, how you calculate. Let us take one example for this one. Odd data again. So here you have 30, 40, 10, 20, 50. So first arrange in ascending order. So visually if you see 30 is the median over here visually. But if you try to apply the formula, what is the formula? N plus 1. Sample size is 5. 5 plus 1 divided by 2. 6 by 2 is nothing but third term. So what is the value that is following, that is falling on the third position? 30. So whether you apply the formula or you see it visually, you got the median. So that is a median when it is odd. Similarly, you can apply for if it is even. So median of the data, if it is even, what will you do? So sample size is here 6. So you have to try to calculate over here. So let us just calculate over here. So n plus 2, this is the formula you're supposed to apply. N is 6. 6 divided by 2, it is nothing but third position. Okay, third position plus, so 6, 3 plus 1, that is nothing but fourth position. The third position plus fourth position divided by 2. So what is the number that is following at the third position? 30. And the number that is following at the fourth position? 40. 40 plus 30, how much? 70. 70 divided by 2, the median is 35. Like that. The median is 35. This is the answer. Did you understand how did I do? N is over here 6. So 6 by 2 is third, 6 by 2 plus 1. 6 by 2 is 3. 3 plus 1 again 4, like this. So this is how is the median calculation. Then next is, so let us learn about median. Median is always the middle value in an ordered data set. This is very much important. So this can be useful if you are trying to use the data set that contains outliers. So how to determine the median? Always order the values from least to greatest. Locate the middle value. And if the number of values is even, sometimes the median is the average of the two middle numbers. So if it is even number, it is the average of the two middle numbers, like that also. This is the other way you can calculate median. So that is about the median. Next is mode, the most easiest. So mode is nothing but the most number that shows up most often in a data set. So you can have more than one mode for a set of data. This is called as bimodal. So which is the most repeating number. So if you see in this particular data set, this is an example. You can see 67, 67, 67 is repeated. So the number that shows very often is called mode. So this time the mode is 67 because it is showing multiple 3 times. So mode is nothing but that occurs most often, and this also can be used when it contains outliers. So important interview question for biostats. Which central measure of central tendency is useful when it contains outliers? Median and mode. But mean cannot be calculated using outliers. You have to remove outliers if you are displaying mean. So if there is no mode in the data, then it is of no use. Such data is not used at all. So mode is not popular as mean or median. In any statistics, we don't use mode. We are just learning, but in any data, if you want to show the data in a clinical study report, we use only mean. We don't use median and we don't use mode also. But we're just learning these are measures of central tendency. Okay. Yes, Lakshmi Shankar, you are right. So sometimes there are modes over here. Sometimes in any data like this here, you can see in the screen, you can see here, you order the values. So mode can be like you said here, like I said in the previous slide, sometimes we can have more than one mode. So if you have one mode, it is unimodal data. And if you have, like, for example, in the second line, number 5 is repeating 3 times, number 6 is repeating 3 times, but 8 is receiving only 2 times. But however, 5 and 6 are repeating 3 times. So you have two modes in this case, 5 and 6. That is called bimodal. And if you don't have any mode, it is called as no mode. But such a data is a waste data if you don't have any mode. So modes can be unimodal if you have one mode. If you have two modes, it is called bimodal. And if you have more than two modes, then it is called as a multimodal data. So like that, you have both, you have this thing. Now what I want to say over here is, even though we have learned mean, median and mode, mean is the only measure of central tendency that is used in any statistical report or clinical evaluation report. Okay, so that is all about mean, median, mode. So this is one more example where we can see where you have this number 3 and number 9 also is repeated twice. So such a kind of data is called 3 and 9. Okay. Okay. So there is a question, why a data with no mode is of no use? So statistically, there are many researchers and scientists who have done mean, median, mode, and they have done a lot of statistical tests. So what they found that if any data is having no mode, no, they are telling it is of no use because it is giving a lot of errors in the results. So if you don't have things in common, like for example, when I'm trying to do an efficacy of the drug, let us say on a blood glucose parameter. So before the giving any the drug, let us say antibiotic I am giving and I'm testing on an infection rate. So the infection got reduced on the first day in 30% people, 40%, for 30% or 40%, by 40% or 30. Second day again 30 and 40, third day 50 and 60. But on the first day, I'm getting all different values. I'm not getting similar. Then do you think the drug is actually working or is it because of some other reason? Right? So if the drug is really working, it will give some common things in every data. In every value, you should see some common result. That is why if they say there is no more, such a data set is of no use. That is what they found because it's not common. Similarly, if you say height and weight of people, majority of the weight of the people will be 50, 55, 40, 44, like that. But if you take 20 people and in the 20 people, the weight has to be somewhere between 50 to 60 commonly. And somewhere the height also should be between 150 to 160 centimeter. So there should be some common things. If you don't have common things, then it means there's a lot of variation in the data. When there is variation, lot of variation, how can you, what do you call, conceptualize the result? How can you say that yes, this particular drug will show the efficacy on all the population? How can you say that, generalize that result? So whenever we are doing sample, no, on 5,000 people, whatever result we get, we have to generalize that to the population. So when you say what is a sample, it is a representative group of the population. So what I am claiming, today my drug is showing efficacy in 5,000 people. It means it will also show efficacy in all the population, like that. That is why I'm launching in India. I did an Indian sample, I'm launching in India. But if my sample itself had a lot of variation, everybody's biological parameters and biochemical parameters are different, not nothing in common, then I feel there's a lot of variation, different people are there in your data. How can I say this result will apply to general population? You don't have general population only in your sample. Everybody is different only. So that is why they say if there is no mode, it's of no use. So is it clear, Lakshmi Shankar? Yeah. Yes, thank you. Okay. So that is about mean, median, mode, and this is one example. So now here you have to say what is the mode here? Do we have mode or do we don't have mode in this data? So we don't have mode. Yes, yes, you're right. So yes, so Lakshmi has responded. There is no mode here in this data. Yes, thank you everybody for your response. Yes, Mr. Praveen. So there is no mode in this data because nothing is repeating. So so in MCQs, like when you go for statistical interviews, if you want to pursue your career or you want to take a aptitude test for a statistical test, they might give you such one small MCQ like this, and they say calculate the mean, median, and mode, and 1 minute time they will give you. So for the same data, if you want to calculate mean, sum up all the values divided by total sample size, 28 by 6. So what is 28 by 6? 6 fours are 24, and then you will have 4. So 6, what is 6 for 40? Yeah, 6 6 are 36. So 4.6, like that you will get somewhere. Now, furthermore, what you are do, what is the most repeating value here? 7. 7 is the mode over here. You got the 7. Then what is a median? You have to arrange it in ascending or descending order. So in this particular example, this entire data is arranged in by the descending order. So 7, 7, 6, 4, 3, 2, 1. So what is the middle number that is following here? 6 plus 4 divided by 2. So 10 divided by 2, it is 5. So median is 5, mean is 4.6, and mode is 7. So like that, that are the measures of central tendency. Okay, so next we will learn geometric mean in next class. Before that, I want to show you the normal distribution curve. So give me a moment. So this is a statistical software, that is SPSS. So this is usually used only for academic and research purpose. I mean, hospitals or colleges or universities or hospitals, that's all. But for clinical trials, this is not used because government has restricted. You have to use only statistical software or R. Okay. So like this, you have how many sample data you have here? Can you see here? 10,000. Can you see at the bottom of the screen? I cannot zoom the screen, but you can see here. 10,000. So this data is having such a huge data. Now, how do you calculate when you have such a huge data? So with just only one tool, like suppose I want to calculate what is the average age of someone. So simply I'll go to analyze, and there I will have, let me just get down the tool. Okay, analyze. So here you have descriptive statistics. So in descriptive statistics, I'll be having all the descriptives. I can go for age, I can go for variable, I can go for options. I want mean, I want minimum. All these are measures of central deviation, that is variance and range. So that we will learn later. So as I said, median and mode is not much calculated. We have only mean, standard deviation. Variance and range are measures of measures of deviation. So this we are learning in upcoming classes. So suppose if I calculate only the mean, if I want to calculate only the mean, and I can just go okay, then I will get the average age. What is the sample size here? 10,000. So you all can see the screen. So within just a matter of seconds, I just got 43.77 is the age. Okay. So like that, we will be able to what do you call go for this thing. Okay. So suppose I want to also see the graphs. Okay, just give me a moment. So before setting on the graphs, I have to, so suppose I go for descriptive statistics and I go for cross tabs. Okay, so I'll go to these things and then I'll go age and I'll go by customer ID. So if I want plots, I can go for 1 second. Okay, total is not there, so that is why it is not coming. Okay. The system is hanging. So we will get the plot. So suppose I have taken income category and all these things. Let me show you the normal distribution curve. Okay, I was talking about normal distribution curve. Can you all hear me? Yeah. So you all can see this curve, bell-shaped curve. Is it visible for you guys?
Yes, ma'am.
Yeah. So if the data is like this, it means my data is normal. And here on the screen, I got here mean, standard deviation, and for income category. I have used for age and income category. So I will see as per the income and age I have taken. So if I am trying to compare demographics based on income status, I'm using this data. So if my graph in the statistical analysis will come like this, it means it is left skewed. Or if my graphs comes in this way, it is right skewed. That time I should decide different kinds of test, like here in this kind of we will study in upcoming classes all that concepts we are studying in upcoming classes. So under analyze tab, I have Bayesian statistics. I have here different types of statistics. So I have ANOVA test and t-test and regression, correlation, and again I have different models and different tests I have. So these things I will be doing if my data is not normal. So in that case, I'll go for different kinds of test. So like that, you have the option both normal distribution and not normal distribution, and how your data has to be. So that way you will get completely the output in one fraction of seconds. And I will show you the output page. If you see the output page, you will get different kinds of data, different plots you will get, and you will also find the outliers. So we will study in upcoming classes outliers. These are the outliers. The data that is following outside the box are called outliers. So whenever there are outliers, I should remove these outliers or I should replace these outliers by the mean. So like that statistics is very much in detail. We are learning an overview because we can't complete in 1 month actually. It's very much in detail, very big concept. It will take, 2 4 years to completely understand statistics. But overall, we are learning. From today's class, I just want to give you a takeaway point that mean median mode always lies in the center of the data, and the data which is in bell-shaped curve itself is called as a normal distribution curve. Okay. So then we have in mean, we have geometric mean, we have some other types of mean like arithmetic mean. So we will take up geometric mean. We still have little bit time. With that, we will complete. Arithmetic mean is nothing but the mean that we have learned till now. So we'll just finish geometric mean. Then next class we can take measures of deviation. So, geometric mean is nothing but it is used in certain situations that we will learn in next slide. But how do you calculate geometric mean is you have to take the root, nth root of all the product of n positive numbers. So, suppose you have here the data 1, 2, 3, 4, 5, and sample size is 5. So in arithmetic mean, what you're doing, you are summing up and you're dividing by 5, you got the mean. In geometric mean, the sample size will become the square root 5, and this you are doing multiplication, product, you're taking out the product, multiplication. So you multiply all this and you take the square root of this, you get the geometric mean. So somewhere it is near only. So in what situations you will use geometric mean is the idea now what we are learning. If your sample is your data that you're collecting is in ratio or percentage. Suppose I will ask you, what is the actual infection rate? How much better you feel today from yesterday to today? 90% better or 80% better or 70%? You will say 80% I'm feeling better. So if you're collecting your raw data itself is in percentage, what kind of data are in percentage in real life example? Geometric mean is not used in clinical trials. I'm just, we are learning this only for our knowledge. So what kind of data is in percentage? Have you seen in mutual investment funds? If you invest for next 5 years this much amount, after 15 years you will get 10% returns. What is that percent? So if your data itself is in ratio and percentages, then you will use geometric mean. It is used to compute average rate of increase or decrease like in stock markets and exchanges. So it is also useful for construction of index number. What is index number? Have you heard about recent news? The air quality index AQI in India, in Delhi, has gone worse after Diwali. So AQI, that is called index. How this index is calculated using geometric mean. Similarly, recently our external foreign minister, external affairs minister Jai Shankar has given a talk. He has addressed in media. Somebody has pointed out even in our BJP government, the hunger index has not increased. So how do you calculate that hunger index and all that is using geometric mean. So this is what we should remember. Based on data, what you have to use, that is where biostatistician roles lie. So like investment returns is one example. Suppose you invest in a financial asset and returns over 3 years is recorded like this 5%, 10%, 15%. So you want to calculate what was the overall average return. So you will apply the formula and you will get overall return was 8.66 in all the 3 years. It is fluctuating, no? It depends upon the stock market. So like that. Similarly, population growth. If you want to find what can be the annual population growth in the next coming years or something like that. So suppose a population will grow by 10% in the first year, 8% in second year, and 12% in third year. What is the geometric mean? So you have to, because they are telling first year 10%. So it is calculated in every year basis. So they are taking the formula as 1.10, 1.08, 1.12. Why? Because 1 year they are calculating. So like that, if you calculate, it is the average percentage increase is 9.9, like that. Similarly, average rate of infection. So during COVID, in the first week, 3 weeks, the infection rates was like this: 20% in first week, 30% in second week, 40% in third week. So if you want to calculate what is the rate of infection spread, so whenever you have the data in percentages, then you will use geometric mean. So here you got the average rate of infection spread is 29.5. But if you look at the data, you're telling 10% it is increasing. No, average rate of infection is 29.5. In next week also we will have 29.5% of infection rate, like that. Next is environmental pollution indices, like I said, pollution index. So for all these type of questions you will get in your aptitude test also. If you remember, I have come across such test. They will give the percentage of harvest of crops in this year was 10%. In next year it was 30%. What will be the average rate in the next year? How will you predict the future? You will think, but this is where you will apply geometric mean. So like that. So environmental pollution index. So when you are measuring pollution levels in different areas, but at different times. So you got the index, you rated the scale from 1 to 10. So in three areas, you got the index as 5, 3, and 7. So if you want to calculate the overall pollution index, so apply the square root of 3 and apply here, you will get this formula. Similarly, stock price ratios. So in stock analysis, you want to know what is the average price to earnings, how much price you have invested and what were your earnings ratio. So this depends. So if your price per earning ratio for three stocks are like this: 15, 20, and 25. Ratio you're writing here. The data is in kind of ratio. 15 is to 20 is to 25. So what is the geometric mean? How will you calculate the average ratio of all the stocks? You will multiply this square root of this. You got the average stock ratio is 19.49. So whenever your data is in ratio and percentages, you will use geometric mean formula. So that is it. So we have learned mean, median, and mode. Next class, we'll be learning measures of dispersion. So what we learned is mean is the common measures of central tendency and standard deviation is the common measures of dispersion. So in the statistical software, just now we saw mean, but we didn't saw median and mode over there. But in measures of central deviation, we saw range and we saw variance. We did not see quartile deviation and absolute deviation. So these three things are common in measures of dispersion. So that only they use. So we'll be learning that in upcoming classes. Any doubts so far, everyone? Okay. Yes, thank you, Lakshmi. Yes, thank you, everybody. So I'll end my session here. I'll see you all tomorrow. Thank you, everybody, for your patient listening. Thank you, everyone. Have a good night. Yes.